NASA has planned to build a base on the Moon before sending people to Mars to streamline the process of sending people to Mars in the future. The CEO of SpaceX, Elon Musk, wants to win the title for sending the first people to Mars for the first time in history. Although European and Russian space agencies are running the same race to send the first person to Mars. But how can a human survive the harsh conditions and lack of oxygen on Mars after landing? How will NASA produce oxygen on Mars? And why is the method of generating oxygen in international space stations not applicable on Mars? Welcome to Fascinating Anecdotes. The wish of human beings to reside on Mars consists of various reasons, including scientific explorations and space curiosity. One significant factor is the fear of mass extinction of humans from Earth, similar to what happened with dinosaurs 65 million years ago. This incident could occur again, given the early signs of a potential global disaster in the form of climate change. In December 2020, Elon Musk predicted colonizing Mars by 2026 with humans. But he has since revised the predicted date to 2029. On the other hand, NASA has also predicted landing people on Mars by 2030. However, the key question is not merely being the first to land on Mars, it's how they will survive the harsh conditions. Although many properties of Mars are similar to those of Earth, such as a Martian day length is only 39 minutes longer than Earth's, different weathers, atmospheres, and ice caps on their poles, the one thing that makes Mars inhabitable for humans is the lack of oxygen. So, how will oxygen be generated on Mars for a whole colony to prosper? Addressing the challenge of surviving harsh conditions, the International Space Station, ISS, has been continuously generating fresh oxygen and water for the space crew for the last 25 years. The crew requires 16,200 liters of water and 1,000 kg of oxygen per year. To meet these requirements, two systems are installed on the ISS. The water reclamation system, which collects water from urine, sweat, and humidity and filters it into clean drinking water, and the oxygen generation system, which takes some water from the water reclamation system and converts it into oxygen gas through the electrolysis process. Although this system is 98% efficient, but it requires water to be sourced from Earth once every 6 months. However, these refueling missions are costly, as it takes $2,500 to send 1 liter of water to 400 kilometers above the Earth's surface to the ISS. So, generating oxygen on Mars, which is 225 million kilometers away from Earth, is not cost-effective at all. Scientists are exploring ways to generate oxygen within the available resources on the Red Planet. In 2021, NASA placed a small device called MOXIE on the Perseverance rover sent to Mars. Its purpose is to generate oxygen by condensing CO2 gas obtained from the Martian atmosphere and heating it at high temperatures in an electrolyzer to separate oxygen from carbon dioxide gas. The electrolyzer is made of gold because gold is an excellent conductor. Since this device requires a significant amount of energy, it is only operational when excess solar energy is available. To date, MOXIE has produced approximately 122 grams of oxygen, enough for an average human to survive for only 3.5 hours. Scaling up oxygen production poses a challenge. Scientists would need to create a larger version of MOXIE, requiring an entire power plant to make it operational on a large scale. This undertaking presents a significant hurdle in the quest to produce oxygen on Mars. Scientists are working on different technologies to solve this problem, but haven't reached any conclusion yet. The end goal is to develop a sustainable oxygen generator entirely dependent on the available resources of Mars, with no dependency on Earth. As we conclude this video, we want to express our gratitude for your time and support. Your engagement means the world to us. If you enjoyed this content, please don't forget to like, share, and subscribe.